Welcome to Data Structure course. Hi, I'm Swapnil Chaudhary. Today we are going to see algorithms for circular queue with tag. In my previous session, what we learned? We learned circular queue, but there is a problem with a circular queue. First problem is we cannot utilize efficiently all the memory locations. Since suppose we insert element here 10, 20, 30, we initialize front and rear to uh, zeroth index. Okay, 0, 1, 2, 3, 4. So size of this queue is what? 5 elements. Now I'm insert one more element here, so means my rear is pointing to here. Now suppose I'm going to insert one more element. That time it checks whether front and rear both are pointing to same position, so we cannot utilize this memory block. First problem is this. Now second problem is what? When we are going to insert in circular queue, that time we are going to check if rear is equal to front, means both are pointing to same position, means what? Queue full condition. Likewise, when deleting or removing element from circular queue, again same thing. What we are going to do, we are going to check front is equal to rear. The meaning is same. It creates an ambiguity, means what? When we are checking for queue full condition, we are using same condition like rear is pointing to front, and when we are going to check the empty condition, that time again we are going to check front is pointing to rear, means what? It is the same condition for front and for empty and full condition. So this ambiguity we are going to overcome in circular queue with tag. In circular queue with tag. Okay. So let's start with the first algorithm. So basic operations that we are going to perform on circular queue with tag is what? Create, then add in circular queue, then delete from circular queue, then we are going to check queue full condition and queue empty condition. So these are what basic operations which we are going to perform on circular queue. So in circular queue, what we are going to do, we are going to write algorithm for create first. Okay, so so create circular queue with tag. CQT means circular queue with tag. So here we are going to declare the size of circular queue. So I am writing the name of array like CQT of size from 1 to n. Okay, of size 1 to n. In create function, I am also going to use declare some variable like tag is initialized to 0th index, then rear is also initialized to 0th index, and front is also initialized to 0th index. So in circular queue create operation, what we are going to do, we are going to declare this array circular queue array, then we initialize tag is equal to 0, rear is equal to 0, and front is equal to 0. Okay, then next algorithm is algorithm for add element in circular queue. So add in CQT. Basically this algorithm takes as an input atom, then the array CQT, then the tag variable. It is a kind of flag variable. Okay, sorry, tag variable, then the rear pointer. Okay, basically this algorithm inserts an atom into the array CQT of size 1 to n. Okay, now before while we are going to insert, we are going to check the first condition if your queue is full. So here what we are going to do, we are going to use a tag variable. What we are going to do, we are going to use tag variable to check queue full condition. We in a create operation, in a create algorithm, we initialize our tag to 0, rear to 0 and front to 0. Means what? We just created our array and we initialize this variable. So when we just created our array, that time queue is empty conditions. Okay, queue is empty conditions. So here we are going to put if our tag is equal to 1. If our tag is equal to 1, then call queue is CQT, circular queue with tag is full. If our tag variable whose value is equal to 1, then call CQT is full, means circular queue is full. Else in else part, if it is not satisfying this condition, if tag is not pointing to tag value is not 1, then we are going to find a rear position. So rear is equal to rear plus 1. We are going to use same formula which we used in a circular queue without tag. So rear is equal to rear plus 1 mod size, and then at that rear position of circular queue with tag array, at the array circular queue, at that rear position we are going to insert that atom, and after that what we are going to do, we are going to check the next condition, that is if your queue's front is equal to queue's rear. If front and rear both are pointing to same position, then set your tag is equal to 1. So here we are assigning the value 1 to the variable tag. And the last statement, that is end of CQT. Add CQT algorithm. So now what we are going to do, we are going to check whether this algorithm working fine or not. Okay, so let's assume that here the size of your CQT n is equal to 5. Okay, so I'm draw circular queue. Okay, so this is what 0 index, this is 1, 2, 3 and 4. The size of queue is what? 5. Now initialize the variable, that is tag is equal to 0, front is equal to 0 and rear is equal to 0. So this front and rear value is pointing to index 0, and this is what tag variable, which it is not a pointer variable, it is a flag variable which hold the value 0. So initially front and rear both are pointing to index 0. Now we are going to insert element, check the condition if tag is equal to 1. What is the tag value now? It is 0. So this condition is not satisfied, it will jump to the else part. In else part what we are going to check? Rear, we are going to find a rear position. So rear is equal to rear plus 1. So what is rear value now? Now rear is pointing to index 0. So rear value is 0. 0 plus 1, 1 mod size. Size is what? 5. And is equal to, size is equal to what? 5. So 1 mod 5, that is 1. Now your rear going to points at index 1. Now at index 1, what we did? We insert that atom, that is 10. What we did? We insert that atom. Okay. that is 10. Then we are going to check if front is equal to rear. What is the value of rear now? That is 1. And what is the value of front now? That is 0. Front is pointing to index location 0. Okay, so front value is 0 and rear value is 1. Condition not satisfied. Front is not equal to rear, so it will not jump to the this condition. End of the executive algorithm. Now again we are going to insert one more element, so it will come here. Tag is equal to 1. Tag is equal to 1 again. No, it is not equal to 1, so it will jump to the rear path. Then again we are going to find rear position, so rear will jump to the index 2. Rear will jump to the index 2. Now at index 2 we are going to insert element 20. After that inserting, we are going to check front is equal to rear. False, since rear value is 2 and front value is 0. End of the executing. Again we are going to add one more element. Check the condition. Tag is equal to 0. Tag is not equal to 0. What is front value now? 0 and rear value is 2. So tag is equal to 0. Tag is equal to 1. No, condition false. Here tag value is 0 and 0 is equal to 1. False, condition false. It will jump to the else part. Now in else part, rear value is 2. 2 plus 1, that is 3. 3 mod size 3. So now rear is pointing to here. Now at this index we are going to insert another number. Now next line, front is equal to rear. What is front value now? 0. Rear value now 3. Condition false. Condition false. End of the executing. Again we are going to insert one more element. So check tag is equal to 0. What is tag value now? 0. And tag value 0 is equal to 1. Condition false. It will jump to the else part. In else part, 3 plus 1, that is 4. 4 modulus of 5, size is 5. 4 modulus 5, condition 4. So now rear is going to point here at index 4. So here I am inserted one more element. Now check front. What is the front value now? That is 0. What is the rear value now? That is 4. Condition not satisfied. It will not jump to this if part. End of the executing. Again you are going to add one more element. So tag value is what? 0 is equal to 1. Condition not satisfied. Jump to the else part. Now rear is equal to rear plus 1. What is the rear value now? 4. 4 plus 1, that is 5. 5 modulus of 5, that is 0. 0. So now at index 0 we are going to insert the element. Now rear is pointing to index 0. Now if front is equal to rear, now what is the value of front? 0. And what is the value of rear? That is 0. Condition satisfied. Condition, now this condition is satisfied. Okay, so if this condition is satisfied, it will jump to the if part and say it said tag value is equal to 1. Tag value is equal to 1. Tag value is equal to 1. Now suppose if you are going to insert one more element here, so it will go to the executive. Now if tag value, what is tag value? 1. 1 is equal to condition satisfied. It will say circular queue with tag is full. Circular queue with tag is full. So you cannot insert more elements. So here we overcome two problems. First is what? We can utilize all the memory block efficiently. That is not possible in circular queue without tag. Okay. Now in circular queue with tag, we can utilize all the memory blocks of array, isn't it? And also here we change the queue full condition. Here we use tag variable to find whether circular queue is full or not. Okay, so now let's see the another algorithm, that is delete from CQT. Okay, delete from CQT. Now we are going to use another algorithm, that is delete from CQT. So let's start with delete from CQT, circular queue. CQT stands for circular queue with tag. Now this algorithm basically takes as an input like array, circular queue array, then type variable, then the front position and rear position. So this is basically input taken by add CQT algorithm. This algorithm basically delete an atom from CQT array whose size is 1 to n. Now before deleting element from circular queue with tag, we are going to check whether queue is empty. If queue is empty, we cannot delete element from that. So first what I need to do, I need to check that condition whether queue is empty or not. Now we already know the queue empty condition. What is that queue empty condition? When we create our circular queue, that time what we declare? We declare our tag value is 0, and second condition is what? Front and rear both are pointing to same position. Second condition is what? Front and rear both are pointing to same position, and if tag value is 0, then queue, circular queue with tag is empty. So if what I am going to check, front is equal to rear. If front and rear both are pointing to same position, then whether it is a 0, 1, 2, 3, whatever, if front and rear both are pointing to same position, same index location, and this is most important part, and tag is pointing to tag value is 0, tag is not pointing, it is a flag value. If tag value is 0, if tag value is equal to 0, not equal to, if tag is equal to 0 and front and rear both are pointing to same position, that means circular queue with tag is empty. Then call CQT is empty. Very simple. Else, if this condition is not satisfying, then simply find the front position to delete element. So front is equal to front plus 1 mod size of array. Okay. Then we are going to use one variable, that is atom. In that we are going to collect whatever element we are deleting. So CQT of front. So in the array at position front position, whatever element we have, we are going to delete that. Okay, and then simply set your tag value to 0. Why we are setting here tag value to 0? Since now in the previous circular queue with tag condition, circular queue with tag add operation, what we did, when your front and rear reached to the maximum size, what we did, we set tag value is 1. Now in delete operation, if you delete the element from the circular queue, suppose if you delete this element, that is 10 from circular queue, means what? This memory block becomes empty, or this memory block is available to insert new element. But if you not change the tag value to 0, we cannot insert that value. That is why whenever you are going to remove element from circular queue with tag, what we need to do, we need to set the tag value is equal to 0. And the last line is end of delete CQT algorithm. Now let's check the delete operation. So What I'm going to do? I'm going to use previous circular queue. Now this is 0, 1, 2, 3, 4. Now I insert here 10, 20, 30, 40 and 50. Now your front is pointing to index 0. Okay. What is the variables value? What is the variables value? Front is equal to 0, and rear value is what? Rear is equal to 1. Rear is equal to 1. Sorry, rear is also pointing to index 0. Okay. Rear is also pointing to index 0. Front is also pointing to index 0, and the tag value is 1. Here tag value is 1. We are using previous condition. Okay, tag value is 1. Now suppose if you are going to delete element from circular queue with tag, what happen here? Check if front is equal to rear. What is the front value? Yes, front and rear both are pointing to sorry, this is 0, no? Front and rear both are pointing to same index location. Front is equal to 0, rear is equal to 0. Both are pointing to same index location. So front and rear, this condition is satisfied. But here we are using AND operator. Means if both condition are true, then and then it will jump to the if part, else it will jump to the else part. So front and rear both are pointing to same position, no problem. Front and rear is both are pointing to 0th index. Condition satisfied. Then it will jump to the else part. Now what is else part? Tag is equal to 0. Now what is our tag value now? Our tag value is 1. See, our tag value is 1. Okay, I'm going to take reference of previous algorithm, isn't it? Now previous example. Okay, so tag value is 1. Condition, see, condition not satisfied. Here tag value is 1, condition not satisfied, so it will jump else part. This is what else part, sorry, this is what else part. Now in else part, what we are checking, we are finding the front position. Now front is equal to 0 plus 1, 0 plus 1. Since we inserted 10 first, then it must be removed first, isn't it? So 0 plus 1, 1 mod of 5, it will produce 1. So now your front is pointing to index 0, 1. Now your front is pointing to index 1. Means what? This element is deleted. This element is deleted. Now what we are going to do, once we delete element from circular queue with tag, we need to set our tag position to the 0. Our tag position to 0. Now our tag value changed to 0. Our tag value changed to 0. Now again I am going to delete element from circular queue with tag. So here what happened? What is front value? Front value is 1, rear value is 0, condition not satisfied, and also tag value is 0, but this condition is not satisfied, and here AND operation, so it will jump to the else part. So front is equal to 1 plus 1, that is 2, mod size, that is 2. So front is going to point index 2. Front is point to index 2. Now atom means we are collecting those atom which is at front position to atom variable which is deleted. Now set tag value to 0 as it is. So tag value already 0. Okay, we are again setting the tag value. Means what? This element is deleted. Again I am going to delete this element. Okay, what is front and rear value? Front value is what? That is 3 is equal. So sorry, 3 is not pointing now. We are going to what is front value? 2 is equal to 0, condition false. Since rear is pointing to 0, condition false, it will jump to the else part. Now find the front is equal to 2 plus 1, that is 3. Now front is going to point this index location. Mod size, so this element is deleted. Set tag value to 0 again. Every time we are going to set tag value to 0 every time. So this element is deleted. Again you are going to delete one more element from here. Now what is front value? That is front is pointing index 3. 3 is equal to 0, condition false, it will jump to the else part. 3 plus 1, that is 4. 4 modulus of 5. Now front is pointing to here. Means what? This element is deleted. Again I am going to delete one more element from circular queue with tag. Now what is front value? That is 4 is equal to 0. What is rear value? 0. Condition false. It will jump to the else part. 4 plus 1, that is 4 plus 1, that is 5. 5 modulus of 5, 0. My front will going to point again. Index 0 means what? This element is deleted. Now all the elements of circular queue is deleted. Let's check queue empty condition. Now again I am going to delete one more element. What is the front value now? What is the front value now? That is 0. What is the rear value now? That is 0. Front is equal to rear. Condition satisfied. And let's check tag value. Tag again we set to the 0. Every time whenever we delete element from circular queue with tag, we set our tag value to 0. Okay. So again this condition is satisfied. So it will say circular queue with tag is empty. We cannot delete more element from circular queue. So this is what delete circular queue with tag algorithm. So now you can observe that we overcome the second problem, that is queue full and queue empty condition as well. Here we are checking queue empty condition is equal to what? Front is equal to rear and tag is pointing to 0. And here queue full condition is what? Tag is equal to 1. So there is no ambiguity in these two statements. Now in our upcoming sessions we are going to see the implementation part of circular queue, since it is a part of our syllabus practical sessions. So we are going to see implementation of circular queue with tag in our upcoming sessions. Okay, thanks for watching this video.